Okay, hello. We are done the homework, me and my classmate, teammate, Atakan Yontar. We built our solution together. Okay, now I'm getting started with our homework solution. However, we cannot implement the A-star algorithm. We cannot figure it out. Now I'm starting the homework. Okay, as you remember, our data structure has been declared as digraph. So we are come up with this py file. Our code defines a set of classes to represent the directed graphs. There is a node class here, which represents a node in the graph, and the edge class, which represents an edge in the graph. Edge has source and destination nodes. Actually, these are nodes. The edge class can be subclass to create a weighted edge class, which includes information about the weight and the weight of the edge. As you can see, our edge is used in weighted edge initializer file, and then distances and the total distance and the outdoor distance have been set on the edge, which is outdoor is the green one, total distance is the blue one. And there's also our digraph class, which represents the directed graph made up of those nodes and edges. The digraph class has methods for adding nodes and adding edges to the graph and for checking whether a node is in the graph. Finally, there is a unit test to ensure that the classes are working as expected. These are come up with the solution check call files. Let me run it. As you can see, we passed all tests. Also, these functions are part of the Python class digraph, which are our two functions that used in here. Let me give it to edges and edge. Okay. Now where should I start? Keep continuing this. Okay. We've been read the file MIT map.txt. As you can see, we read each line for every line. For every line, we are holding a list, map list, for in Python, which is an array. After we created our digraph, I keep continuing the reading every file, split it by the spacebar. Our for loop is increasing by 4 in every 4 iteration. Now it's the main deal of our project, of our homework, is the get best path. The function get best path takes as input as a directed graph, as you can see, digraph, a starting node, end node, a current path, and a maximum distance of outdoors, and best distance and best path. Okay. Now, if there's no path, we are returning actually our path 0. It returns a tuple containing the shortest path between the starting and ending nodes, represented as a list of the node names, strings, and the total distance traveled along that path. If there is no path that satisfied the constraints, then it returns none, as you can see here. Why it with this and this means none, as you can see here. If path is none, we are returning the non-tuple, which is 0. Function uses a recursive approach to explore all possible paths between the start and the end nodes, keeping track of the shortest path found so far that meets the constraints. The path parameter is a list that constrains 3 elements: a list of node names representing a current path, the total distance traveled so far, and total outdoor distance traveled so far. The function first checks if the path parameter is none, and if it is initialized it as an empty list. It then appends the starting node to the path, as you can see here. And then next it checks if both the starting and ending nodes exist in the graph. If either node is not represented in the graph, it raises a value error, as you can see here. If the starting and ending nodes are not the same, are the same, it returns the current path, since there is no need to explore further right here. Otherwise, we are jumping here. The function iterates through all the edges originating from the current node. For each edge, it checks if the destination node has already been visited. Okay, now we are checking here. If it's not been visited, it computes the total distance and outdoor distance traveled by adding the edge's distance and outdoor distance to the current path's total distance and outdoor distance, respectively. If the maximum outdoor distance allowed is greater than or equal to the new total outdoor distance, the function creates a copy of the current path and updates its total distance and outdoor distance using the computed values. It then recursively calls the get best path with the destination node as the starting node, the update path as the current path, and the best distance and path found so far as parameters. Thanks for watching. Actually, directed DFS checks the best path, which is bigger than maximum total distance, none or best first. If it's occurs, raises value error. If not, keeps computing and returns the list of best path. As you can see, the unit tests are here. Let me run it. We run 9 tests and all passed. Thanks for watching. Let me close the meeting.